Okay? You guys need to listen very carefully when we're going to do this work, because we're going to go through it quickly so we can once again get to old question papers, because you're going to see, especially with this, the type of questions that we see in the textbooks is not on the same level as the ones that we get in question papers. Okay. Right, so, but in order to answer those questions, you need to know the basics very well. Very, very, very well. Okay. So the linear pattern, the first difference is constant. So when you have a number pattern, like for instance 5, 7, 9, 11, you would get the difference between them, right? The first time. Then you get a first constant difference. That means when you subtract the second one from the first, or the first one from the second, and the second from the third, and the third from the fourth, you do it the first time, and the difference is the same. Okay. Do you remember how this works? What we would then do is we know that that constant difference, this one, is the B value. When we look at the formula Tn equals to Bn plus C. So that plus 2 goes in the place of B. And then you ask yourself, what does that value, in this case 2, need to be the first term? What does 2 need to be 5? Plus 3, and then you've got the formula. And that was it. Okay, so if I give you a number pattern and I ask you, is this linear or is it a quadratic number pattern, the one that we're going to learn this year? You're going to take the difference, and when you take the difference the first time, it's constant, then you have proven or showed that this is a linear number pattern. Do you remember the equation of a straight line? Y equal to mx plus c. Y equal to mx plus c. Linear, straight line, same format. Okay. That brings us to grade 11 work. And listen to me, they still ask the linear number patterns as well. Okay. So you need to look at the question before you answer it. Either they will tell you it's linear or quadratic, or when you take the difference, you will see, okay, the first difference was constant, therefore I know it's linear. And then you can highlight here the second part, which says second difference constant. So now you understand why it's important, why we highlighted it at linear. Okay, then you can write down that number pattern. Okay, you're done. Now, You must look carefully. I want to show you that linear number pattern as well. So when I take this difference, what is 7 minus 2? 5. What is 40 minus 7? 7. What is 23 minus 14? 9. Eh. Wait, look first. I took the first difference and it's not constant. Now I take the difference the second time. What is 7 minus 5? 2. What is 9 minus 7? 2. So the second difference is constant. But now before you write this down, I just want everything on the board there. That was our linear number pattern, no? This is our quadratic number pattern. If I close the first line, what do you see there? They're the same. So listen to what I'm saying, every quadratic number pattern has a linear number pattern inside of it. Every one of them. So if I'm asking a question in a paper, I'm asking you about what will the seventh number in the first difference be? This was the first difference. This is the linear pattern. So I'm actually asking you to consider this as a linear pattern and calculate the seventh term. Do you understand? Okay. You can now copy it. I will show you how we get the formula now once we have that. Okay, now here is the part of the work that you're going to have to learn. And if you don't learn it, you won't be able to do anything with number patterns. Switch off your phone, whoever. Was that a phone? Rather a phone. Okay. So do you see we've got 3 lines here? Okay. We're going to have 3 equations to find the formula. Now, we haven't done functions yet, but when we're going to do functions, you will see that a quadratic function, when you did it in grade 10, we only had something like x squared minus 4. Ne? And then it was a parabola and you drew it. But what does a quadratic trinomial look like? It's got something, a x squared bx plus c. Ne? Ax squared plus bx plus c. The ones that we factorize, the haki. Ne? That's a quadratic function, a quadratic trinomial. Now when we write a quadratic number pattern, that's going to be the format that we write it in a quadratic trinomial. Okay? That's why we need 3 equations. You will remember I said if you've got 1 variable, you need 1 equation. If you've got 2 variables, you need 2 equations. If you've got 3 variables, you need 3 equations. So, we're going to have to find a value A. We're going to have to find a value B. And we're going to have to find a value C. 3 variables, therefore we need 3 equations. Do you understand that? Okay. So what the formula looks like, remember linear was Tn equal to Bn plus C. It already had 2 variables. So the quadratic one, I just want you to write it there, is Tn equal to An squared plus Bn plus C. Do you see there's the linear, the one that we know. So all that we are learning about now is the an square, the quadratic term, because it's a quadratic number pattern. It makes sense, eh? Okay. So the first equation, I'm going to put all of them on there now. 2a, we're going to use, I'm going to show you now how, but we're going to use with the first line, or the bottom one, the second difference. 3a plus b, we're going to use with the first difference. And a plus b plus c, we're going to use with the quadratic number pattern. Okay. Right. Now the way it works is we actually doing this. 2a equal to 2. 3a plus b equal to 5. A plus b plus c equal to 2. That's what we're doing. But I'm just going to do the sums here at the bottom because we don't have space there. Can I solve a plus b plus c equal to 2? Now. No, because it's 3 variables. Can I solve 3a plus b equal to 5? No. No. Can I solve 2a equal to 2? No. Yes, so that's going to be where we start. So what is the value of a? 1. Then I take the answer that I got there. So you see, you're going to use the answer to calculate the next. So you have to pay attention. Because if you make a mistake at one of them, it will influence the rest of your answers. And I mark with your mistake, but remember, we're going to do calculations with these equations later on. And if you don't have the right trinomial, you've seen how we factorize a trinomial that doesn't have a nice solution. It takes long and it's hard, and we waste time. So rather pay attention here that you do it correctly. So now we're going to say 3 bracket 1 plus b is equal to 2. Equal to 5. Excuse. I'm already giving the answer. Equals to 5. And then I take that 3, that's multiplied with 1 is 3. I take it over to the other side. And remember, here we divide, but here we're going to subtract. And it sounds stupid that I'm saying this to you, but you guys make mistakes here. You divide again. It's divide, then subtract. Okay, so it subtracts, and then b is equal to 2. Now I substitute back in here 1 plus 2 plus c is equal to 2. Do you understand? Everyone? Okay. So that will give me 3. And I subtract it on that side. And my answer is negative 1. And now I write that in the equation. Tn equal to n squared, because it's a 1. Ne? Do you understand why? 1 plus 2n minus 1. And there you've got the trinomial for the quadratic number pattern. Is that odd? No, I don't think so either. I'm going to do a couple of examples with you, and then I'm going to give you homework. Can I page? Okay, right. You can write activity 2 or exercise 2, page 58, but I'm doing them with you. Okay, there's something else I just want to tell you. You can make a note of it somewhere. When you've got a quadratic number pattern, you need at least 4 terms in your number pattern. Because if you only have 3, you will get 2 differences in the first difference, but then you will only get 1 difference in the second difference. So you won't know if it's constant because you've only got 1. Do you understand what I mean? So therefore we need to have 4, at least 4 terms. Okay. They're saying consider the following number pattern. Show that this is a quadratic number pattern. How do I show it's quadratic? It has a second constant difference. So what I'm going to do is I'm going to check from 6 to 13, 7. From 13 to 22, from 22 to 33, 11. And then I take the difference again for the second time. What is 9 minus 7? What is 11 minus 9? Then I say thus quadratic number pattern. Question 2. Write the next 2 terms. Okay, now this is not as easy as it used to be. Okay? So you're going to start at the bottom. Add 2 again. So I'm going to say the number that I must add here is 13. So the next number will be 46. And then the number that I must add is 13 plus 2 is 15. So the next number will be 61. Okay. So you add the first and the second difference. Next we have to find the nth term. Do you know what it means when they ask for the nth term? It means they want the formula. Okay. Okay, so we're going to take our 3 equations. 2a equal to 2. And then 3a plus b equal to 7. And then a plus b plus c equal to? Okay, so you all understand where I got those answers. So what's the value of a? 1. It's not always going to be 1, eh? It just happens to work out like this now. And now I say 3 times 1 plus b is equal to 7. So b is equal to? 7 minus 3 is 4. Then 1 plus 4 plus c is equal to 6. So what is c? 1. What are you guys doing? And then I can write down the equation. Tn is equal to n squared plus 4n plus 1. And they also asked for term 100. So we're going to say 100 squared plus 4 times 100 plus 1 You type that into your calculator. Now listen to the next question. Determine which term will be equal to 118. What is this question asking me to calculate? Which variable? Which term will be equal to 118? N. They're asking me to calculate n. When they say calculate the value of term 100, that means n is 100. You need to find the value of it, the answer of it. When they ask you which term will be 118, they are giving you the answer of the term. They want to know which term, which n gives an answer of 118. Okay? So therefore, when we go to D, just write it like this so you know when you study which term equal to 118, you will understand or you know what question was asked. So we're going to say n squared plus 4n plus 1 is equal to 118. Do you see that this is a quadratic trinomial that you're going to have to factorize? Do you see it? Can you remember what it must look like before we can factorize it? Can I factorize it now? Why not? What does the standard form look like? What's wrong here? Donkey, say again. Who said it? Homotso. What did he say? Do you hear that? Every one of you. When you've got a square with your variable, the equation must be equal to 0. Okay. So what I'm going to do is I take the 118 over, and then I will have minus 117 equal to 0. Now listen to me. Do you get a 3,97th term? Can you get a irrational number term? No, you get the first, the second, the third, fourth, fifth, sixth. It can only be a whole number. It can't even be negative. You can't have the minus 10th term. Only whole numbers. Okay. So, when you factorize this trinomial, it will be a hacky factorization. You're not going to have to use the formula. But remember, we said when we did the formula, you are always allowed to use it. You are always allowed. Okay. But I wouldn't even do it, ne? I would say hacky, and if you don't get a whole number, you made a mistake. Okay, that's why I say you must pay attention to get your trinomial right. I'll put the n and I'll put the n, and then I'll take my calculator, ne? And I'll start 117, and I'll try to divide it with 6. It doesn't work. Divide with 7, doesn't work. Divide with 8, doesn't work. Divide with, now you see I have to subtract them. So they must be pretty close to each other. Do you understand what I mean? It won't be, what's half of this? 50, 60 something and 2. That's not going to give you 4 when you subtract. Okay? So the two factors must be close to each other. Okay. So I'll try 22. Doesn't work. 21. Doesn't work. 16. Doesn't work. 15. 15 is close because the answer is 8. 14, 13. Okay, so that's the way you do it. You just trial and error until you get it right, because it must be a whole number. So it's going to be 13 and 9. I want to get positive 4, so it's plus 13 minus 9. So the two answers you get is n equal to negative 13 and n equal to 9. Which one is the right one? 9, because you can't get a negative term. No, you can't. You can get a negative term, but you can't get a negative term. Okay. So this one, you just draw a line through, and then the answer is 9. That means the 9th term will give me an answer of 180. Okay. Yes. How big are you writing? Okay, can we do another one? Shush, shush, shush. Come, write down. Okay, the first question. Show that this is a quadratic number pattern. Do it. Do you agree with that? You got a second difference of 8. Write the next two terms. So I want you to do it. Find the next two terms. Did you get 94 and 137? I want you to try to find the nth term by yourself. Once you've done that, you can also calculate term 100, okay? Term 100 is 39,899. Did you get that? Great stuff. Are you all done? Okay, I'll give you a minute. that one? Okay, can I show you? Alright, so the three values that I got was 4, -1, and -1. Did you get that as well? Then you substitute into the equation. So it's 4n squared minus n or minus 1n minus 1. And then to calculate term 100, you say 4 times 100 squared minus 100, oh, not plus 1, minus 1. And then you get the answer of 39,899. Are you fine? Right, which term is equal to 389? Do you know what to do? Try it. Okay, in a case like this, I would probably have used the formula because of the coefficient in front of n. Do you remember the formula? I don't think so. It says x, in our case it would now be n, is equal to, help me, minus b plus minus root b squared coming back to you now. And then you would substitute into it. The moment that I got the answer 10, it wasn't even necessary for me to calculate the other one. But I just did to show you. And then you've got your two answers, so you know the answer is 10. Okay, what I've added out to you now is in your textbook. It's question 4 of this activity, but I thought that maybe you might not have brought your textbooks. So I only have Afrikaans one. That's why it's Afrikaans, but it's the same questions there. All you have to do is to find the general term, in other words, the nth term, and then calculate the 150th term. That's all you have to do. You don't have to do all the other things, just that. But I want you to do it for all 8 of them. Because, donkey, as I say, next week we're already going to start working out the old question papers, and then you're going to see the different type of questions that we come across. I'm going to show you 1 or 2 in class on Monday again, and then we go into the exam questions. So you need to know these basics extremely well. Okay, please take the time over the weekend to go and study this page as well. Know what's the difference between linear and quadratic. Okay, first difference constant, second difference constant. Every quadratic number pattern has a linear number pattern inside of it. Okay, you can start with this right now. Don't know how much time of the period is left, but you can start, and then you do all 8 of them for me for Monday. You can mark them at the back of your book as well, of your textbook. If you cannot factorize it, if it's going to give you an irrational number, your answers are irrational, then we must use the formula. But you could have done it with haki here as well, but I think personally it would have taken longer because of the coefficient there, because now you've got all the factors of 390 that you must consider, and you've got the factor of 4 and 1 and 2 and 3. So it doubles all your options. And therefore, I would choose to use the formula there.